Right. So the first question is, what is the physical quantity that contains dimensions of? Right. Now, so this kind of questions is better to obtain the dimension of each term quickly, right? So now, if you have some the familiar with the dimension, then you can able to obtain the answer very quickly, right? So that's the importance of having idea about the dimension, right? So you know that what is the how to obtain the dimensions of power? Power mean work over time, right? To obtain the dimensions of work equal to, now you should have idea about the this relation, these equations, right? Force mean work equal to force into distance, right? So then this is the dimensions of force into L, right? So this is the dimensions of work then, right? So let's substitute this dimension to this equation. Then this is the dimensions of work, right? Sorry, this is the dimensions of power. So likewise, we have to consider the each physical quantity, right? The dimensions of force is equal to M L minus ML minus MLT minus 2, right? Then momentum. So momentum mean mass into velocity, right? Mass into velocity, then mass mean capital M, velocity mean LT minus 1. Then this is the dimensions of the momentum. So the question is the first one, right? The first one is for the first question. Then let's move to the second one. Capillary rise of a capillary tube is given by the formula H equal KT over R rho G, right? So each term is described in the question. Rho means density, T means surface tension, the K means dimensionless constant. So that's mean you don't need to worry about the dimensions of K, right? It is a dimensionless. Radius of the capillary tube is represented by the R. Gravitational acceleration is G, and height of the water column is T. Now you have to obtain the dimension of T. So first of all, let's subject the term T. Then T equal to H R rho G over K, but you don't need to worry about the K, right? So let's substitute the relevant dimension. H mean it's the height, so that's mean L is the dimensions of H. R mean radius of the capillary tube, so it is also is T. Rho mean density, density mean ML into the power minus 3. G mean gravitational acceleration, and it should be like this, right? So then if I further simplify this, right? So this is the dimensions of H, right? So this is the dimensions of T. That answer should be the second one, right? Let's move on to the third question. The unit for measuring household electricity consumption is kilowatt hours. The physical quantity that measured by the kilowatt hours, right? So you know that kilowatt hour mean it is mentioned that it is unit for measuring household electricity consumption. So this unit is used to measure the electric energy, right? It is used to measure electric energy. So this is the type of unit which is used to measure the energy. The answer should be the fourth one. In the fourth question, what is the value of gravitational acceleration in kilometer per square minutes since its value is ms minus 2, right? So it is, this question is given in unit conversion, right? So the thing is, now you have to convert ms minus 2 into km into the power minus 2, right? So the thing is, now the theory is, this is the given unit and this is the converted unit, right? So the given unit should be divided from the converted unit, that is kilometer hour into the power 2. Right. So this is very easy, right? So first of all, now in this type of question, especially related with the time, it's better to convert this value into positive, this convert these minus powers into positive powers, even though it can be simplified without changing the position, right? So let's follow this the easiest procedure. Then we can able to cancel these two. So here we have s into the power minus 2 and the remaining terms are kilo. Right. So you know that the question is asking about the minutes, isn't it? Right. So this should be okay. The theory is, you know that 1 minute consists of 60 seconds, right? So in order to convert these minutes into seconds, you have to multiply this given value from 60. That is 60 into, now into the power minus 2, right? So this, then let's substitute the further values for kilo, right? So kilo mean it's a multiple unit which is represent the 10 to the power 10 to the power 3, right? So then it should be 1000 and we have 60 60x into the power minus 2, right? So let's in order to convert this value into positive, let's make a conversion. Let's make the let's take the reciprocal's value, that is right. So if I expand this bracket, so this is the obtained value. Then we can able to cancel these two easily, and in order to convert this negative power into positive, let's bring this value into the nominator position. Then it should be 60 into 60 over 1000. So if I further simplify it, 36 over 10. Right. So this is the way that we convert this value into kilometers per square minutes, right? So the given value is 9.8. So you have to multiply this value from this ratio, right? So this is the answer. To convert this unit, the given numerical value should be multiplied by 36 over 10. So the answer should be the 35.28 or approximately 35.3. So this is the answer, right? So guys, it's better to familiar with this kind of conversions, right? So this is the one of the toughest questions in unit conversion, right? So you have to be familiar, right? Right. So in the fifth question, value of main scale division of a vernier caliper is x centimeter, right? So the division of main scale is equal to x centimeters, right? So n number of vernier divisions are coincided with n minus 1 number of main scale division, right? Here, this is the number of vernier scale divisions that we concern is simple n, right? What would be the least count of this instrument, right? So there's a specific, there are two types of equation to obtain the least count of a vernier caliper, right? So the most easiest way is least count can be obtained by dividing division of a main scale, division of main scale from the number of vernier divisions, number of vernier divisions, right? So if we substitute the relevant values, division of a main scale is x and the number of vernier divisions is n. So this is the answer, right? So it should be the fourth one. And there's another equation which can be used to obtain the least count of a vernier scale, right? So by using that equation 2, you can able to obtain the same answer, right? Okay, let's move on to the sixth one. Displacement of an object is given by the formula x equal to t minus 3p squared plus t cube. What is the displacement when t is equal to, right? So we can able to obtain the answer by substituting the value for t as 2 squared plus 2 cube, right? So if you simplify this, you can able to obtain that the answer as the answer should be 0, isn't it? So the answer is the first answer is the correct one, right? In the seventh question, and you have given a velocity time graph, right? And you are asked to obtain the displacement of the object within that considering time, that is within 20 seconds, right? So the theory is the area of a velocity time graph represent the displacement traveled by the object. So that's the uh, theory, right? So if we now this is the graph which is given in the question, right? So area can be obtained by using the equation, the equation which is used to obtain the area of the triangle, that is half into perpendicular height into base. So base should be equal to 10 and perpendicular height should be 6, right? So the answer can be obtained as 30, right? So that's this part represent the displacement which is towards the opposite direction. So this area should consider it as a negative value. So let's find out the magnitude of this area. It is also obtained as this value. It is also 30. But even though, guys, keep in mind that now if I draw a simple sketch, this motion can be represented as the object is moving towards this direction, and what happened, it is changed the direction of the motion and come to the opposite direction, right? So this is the relevant motion of this object related with this graph, right? So this is this negative axis mean represent the opposite the motion of the towards the opposite direction, right? So this can be considered as a positive 30 and this should be considered as a negative 30. So if we obtain the sum of these two values, then it should be the 0. Now the displacement is equal to 0. That means this object returned to the initial position. Right? So this is the meaning of this graph. And this is the way that we obtain the displacement of the object. So the answer should be the 0. That means second answer. Right. In the eighth question, an object is projected from the edge of a 40-meter height building with a velocity of 20 and 30 ascending angle to the horizontal. What is the time taken by the object to reach the ground? Right. So let's draw a related diagram. So object is projected from a cliff, that's mean from a height, with a value of 40 meters. And the projection angle is 30 to the horizontal. This angle should be 30 degrees with a value of 20. Right. So this is the pathway of this object, right? So the question is asking the time taken to reach this object to the ground, right? So let's apply an equation in a vertical direction, because I have told you that we apply an equation in a horizontal direction to obtain only for the horizontal displacement traveled by this object, right? So now in this question asking about the time. So let's apply a vertical let's apply an equation in a vertical direction. එතකොට දැන් මෙහෙමනේ දාන්නේ. And it is related that we have idea about the displacement and the time. So we have idea about the displacement and asking about the time. So that's mean the time and the displacement is related. So this is the most applicable equation in this kind of instance. S equal ut plus half at squared, right? So when you substitute, now keep in mind that you are applying this equation in a vertically upward direction, right? So this is the initial position of this object, and even though this object is returned to the ground, that's mean now we are applying an equation in a vertically upward direction. Mean in considering about the displacement is considered, we are considered that, so this arrow mean we are considered the displacement values above from this level as positive, and the displacement value below this level as negative. So that's the meaning of this direction sign, right? So keep in mind that. So you have to substitute this 40 as a negative 40, because this object is come to the ground. That's mean this displacement is measured in the negative displacement direction. So that's why we are considering negative 40 instead of positive 40, right? So, and we also have to consider the vertically upward initial velocity. So it should be 20 sine 30 into t plus. So when you substitute in the g, that means acceleration, it should be negative 10 into t squared, because we are applying this equation in a vertically opposite. Always gravitational acceleration is directed towards a vertically downward direction. So that's a opposition, no? So that's why we put this negative sign. Right. So 40 equal 20 sine theta means half minus 5t squared minus 40 equal 10t minus 5t squared. If we further simplify it, let's divide this whole expression from 5. Is minus 8 equal to 2t minus t squared. In order to obtain the quadratic equation, so it's better to convert this expression as a positive square term, right? So that's why I am taking these two terms into the opposite side. That will mean t squared minus t2 minus 8 equal to 0. So if we obtain the factors which is related with this expression, it should be t squared minus 4t plus t minus 8 equal to 0. T minus 4. Right. So that's mean t minus 4 equals 0 or t plus 2 equal to 0. So the answer should be the 4 seconds because time cannot be a negative value, right? So the answer should be the second one, right? So keep in mind these things when substituting the answers, right? Even though you have idea about the how to obtain the question, when you if you made a mistake while doing the substitution, the answer you will get a wrong answer, right? So keep in mind those stuffs. So let's move on to the ninth question. Right. In the ninth question, you are asked to an object which is following linear motion is moving 14 meters distance within fifth second, right? So this object 14 meters in the fifth second, right? During fifth second, and it is traveled 20 meters in the eighth second. Now you are asking to find the distance moved by the object within 15 seconds, right? Now you have to obtain the distance traveled by this object in the 15 seconds, right? So you might remember that I have introduced a simple equation to find out the distance traveled within a particular time period, right? So that is what is the equation? It should be S equal U plus A into N minus R. You don't need to worry about how to obtain this equation, but I have proved this equation, right? How to obtain this equation we already have proved. Even though, just keep in mind this equation. So this equation is used to obtain the distance travel in a particular time period, right? So here U mean initial velocity, A mean acceleration, and N mean the considering time period, right? So let's substitute this equation for the first instance. That is, x should be 5. We don't have any idea about the u and also a, but n mean this 14 meters travel in 5 seconds. So that's mean it should be substituted as 5 minus r. Then u plus a. If I consider the common denominator, it should be 10, it should be 2. Then to convert this 5 into 2, it should be multiplied by 2, isn't it? So that's mean 10 minus 1, 5 equal a u plus 9a over 2. This is the first equation, right? So if I substitute the other fact also, then it should be 20 u plus a. Now here, the n should be substituted as 8 minus r. This half is a constant value. Keep in mind that 20 plus equal u plus, this should be 15 over 2. So let's consider this equation as the second one. Right. So in order to obtain the answer for u and a, we can able to calculate this equation as simultaneous equations, right? So let's substitute this first three equation from the second one. So I'll make let's substitute the first equation from the first equation from the second one. That's mean 20 minus 5 equal u plus 15a over 2 minus u plus 9a over 2. Right. So if I further simplify it, 15 equal to sorry. I have made some mistake here. So this should be substituted as 14, not 5, right? Because x represents the displacement, so it should be 14, not the 5. So 6 equal, u is cancelled, 5a over 2 minus 9a over 2 mean 6a over 2, hence a equal to 2 ms minus 1. So minus 2, right? So let's obtain an value for u. Let's substitute this value for the first equation. If you substitute this obtained value for the first equation, then 14 equal u plus 9 into a over 2. So that's mean u equal to 5 ms minus 1. Right, so we have derived the value for u and a, right? So let's substitute these obtained value into the asking instance. That's mean you are asked to find the distance traveled in the within 15 seconds. So let's substitute this equation. X equal u, we already have idea, that is 5. Now I am substituting the relevant values for these equations, right? A mean 2. Now asking about the 15 seconds, so it should be n should be substituted as 15 1 over half. Right. If I consider the common denominator, it should be 2. And here you can able to obtain the 29. So the answer should be the 34 meters, right? So the answer should be the second one, right? So this kind of questions can be given in exams, right? Because even it is an MCQ, it's a quite there's a quite a large procedure, isn't it? Right? You'll be familiar with this kind of simple questions, right? Okay. So in the 10th question, 150-meter long train entered into 30 meters long railway platform with 40 ms minus velocity. The train passed the platform with 50 ms minus 1 velocity. The acceleration of the train, right? So let's draw a relevant diagram. So let's assume that Peter, this is the train. It is having a 150 meters distance. So when they enter this train into the platform, it is obtain a 40 ms minus 1 velocity, right? So let's assume whether this is the platform. It is having a lawn of 300 meters, right? So when just past the platform, this is the position of the train. So this is the place, this is the point where the train just passed the platform, right? That's mean now let's consider, now I'm considering the velocity of the initial point. Let's call it as A. Okay, now that's mean this A point, that's the front face of this train, have traveled 30 meter, 300-meter distance, as well as the long of the train is 150. So that's mean the A point has traveled 450 meters during this motion, right? So this should be identified. Otherwise, you can't able to obtain the answer, right? So these are the things that you need to highlight or that you need to recognize during these questions, right? Okay. Now let's assume that we have to obtain the value for a, no, and they have given the initial velocity and the final velocity. So the best equation is v squared equal u squared plus 2ax. Now I'm apply this equation for this a point, right? That's mean 50 squared equal to 40 squared plus 2a, x mean 490. So if I substitute this, if I simplify these two, I can able to obtain that 900 equal to 900a. So the a should be equal to 1 ms minus 2. That's the answer for this question, and it should be third one. Third one is the answer for the 10th question. Right. My name is Ina. Weight of AB uniform ladder is W. It is in equilibrium state by tangent with a smooth vertical wall and rough horizontal floor. What is the correct force diagram? Right. Now this is the thing that you need to highlight. Now, if you go through the answers, you can able to find out there are each object they have marked 3 forces, right? So that's mean this object, this ladder is in equilibrium position under 3 coplanar forces, right? This ladder is in equilibrium state under 3 forces, right? And we have learned that there's a requirement if the object equilibrium state, under 3 forces, each force should be intersect at one point. All the forces, that means the 3 forces should be intersect at particular point, right? The other thing is when you mark the forces, if it is a smooth surface, the object only experience a normal reaction, right? If it is a smooth surface, object experience only a normal reaction. Let's assume this is the object and it is always exerted perpendicular to the surface, right? But when we come to the rough surface, it is exerted 2 forces, right? If it is a rough surface, every object experience two forces, that is normal reaction as well as the friction, right? So in some instances, we considering the resultant force of these two, right? So these are some theoretical points. Okay, let's back to the question. Now, guys, now this vertical wall is a smooth surface, right? So if I so I erase this. Right. So let's go through this answer. Let's first of all let's find out how to obtain the accurate answer, right? So this is the way that kept this ladder. I'm using this blue color to represent the ladder, right? So weight obviously should be vertically downwards. It's obviously. And this surface is a smooth one. If this surface is a smooth one, there's only one force that should be exerted. That is normal reaction, and it should be exerted vertical to the surface, right? So these two forces should be you should have to marked, right? So then now there's a force exerted at this point too. That's mean now this is a rough surface. පුතේ මෙතන rough නම් මොකද තියෙන forces දෙක? එකක් normal reaction එක, the other thing is friction, right? So normally, as I mentioned earlier, in some instances we are marked, especially in MCQs, we are marked a resultant force instead of these two, right? So what is the theory for there? Let's consider these two forces. Let's assume that if the friction force is exerted in a vertical direction, and the normal reaction is exerted in a horizontal direction, so the sum of these two forces should be at toward this direction, isn't it? So likewise, normally without marking the friction and the normal reaction, we can able to mark a single force, right? So this is the method that we obtain. What is the direction which this single force is exerted, right? So if I extend this force, so these two forces intersect at this point. So keep in mind that obviously, definitely, the third force should be directed through this point, right? Then these forces should be directed like this, right? R naught. So let's assume the resultant force of these two forces as R naught. So this is the method that where we obtain the correct answer, right? So the answer should be the third one. Answer should be the third one. Right. If you have any doubt, just let me know, right? Then I will sort out those questions, right? Okay, let's move on to the 12th question, right? So in the 12th question, 10 identical coins are placed on horizontal tables as shown in the diagram. Mass of each coin is m. The correct statement is, now the each statement is given the forces exerted on the seventh coin, right? So I think they are asking about the main coin which is concerned here is seventh coin, right? So let's find out the forces which is exerted on the seventh coin, right? So before go to the question, I'd like to draw a simple question like this. Now let's assume whether this is the surface, and if I keep a single coin on this surface, what are the forces exerted on this object, exerted on this coin? The first one is weight in G. And due to this contact between two surfaces, there's a normal reaction exerted, right? So this surface exerts a normal reaction on the point in the perpendicular direction, and according to the Newton's third law, there's the opposite force should be exerted on this surface, right? So this is the basic things that we learned while doing the theoretical things, right? Okay, so let's consider two coins. So I draw the coins with keeping a gap, right? So let's mark the forces. So let's initiate the marking the forces from the free end. So this is the free end, isn't it? Right. So let's the first one is weight, right? So as this contact between these two surfaces, there should be a normal reaction should be exerted. According to the Newton's third law, it is also exerted on the other surface too, right? That is finished. But even though, so if we consider the equilibrium state of this coin, we can be able to mention that R equal to m, right? So let's move on to this object. So it is also having a weight. And due to this contact between the surface, the surface of the coin and the table, there's a normal reaction exerted, right? So it should be marked as R2, and it is also exerted on the surface in opposite direction, right? So if we consider the equilibrium state of this object, we can able to mention that R2, which is exerted in vertically upward direction, equal to R1 plus mg, right? So if I substitute the R1 from the mg, then I can able to obtain that R2 equal to 1g, right? So these are some basic theories. Okay, let's move on to the other thing. So if I draw the 10 points, so this is the 10th one. Right, so this is the 7th one. Okay, let's mark the first mg R1, so R1. So even though R1 equal to mg, let's come to this object, this coin. It is having an mg. It is also experience a normal reaction. Let's call it as R2. And it is exerted on the 8 coins also, right? So if we consider the equilibrium state of this coin, of this 9th coin, we can able to obtain that R2 equal to mg plus R1. But even though R1 is also equal to mg, so then R2 mean 2 mg. Right. Let's come to the 8th point. It is also having a weight, and it is also experience a normal reaction. We see which is exerted by the 7th coin, and 7th coin also experience the same force, right? So if we consider the magnetic equilibrium state, R3 can be equal to, by considering this 8 point, right? R2 plus mg. Even though R2 means 2 mg, then R3 means 3 mg. Let's consider the 7th coin. So 7th coin, so let's mark the forces. This coin, mg. The other thing is R4. This R4 is exerted from the 6th coin, isn't it? Right. So let's consider the equilibrium state of this object. That is 7th coin. Then we can able to obtain that R4 equal to R3 plus mg. R3 means 3 mg. That means R4 should be 4 mg. Right. So let's consider the forces. The force exerted on the 7th coin from the upper coin is 2 mg. That is the 7th coin. No, it should be R3. No, R3 should be equal to 3 mg. So the first statement is incorrect. The force exerted on the 7th coin from the 8th coin is 3 mg. This is the force which is exerted by the 8th coin on the 7th coin, right? So it should be correct, isn't it? Let's move to the third statement. The forces exerted on the 7th coin from the 8th coin is 2 mg. Is it incorrect? The forces exerted on the 7th, sorry, I made a mistake. So they are considering about the 7th coin, right? So the first statement is incorrect. Right, so sorry. I did correctly, isn't it? So this is the force exerted on the 7th coin from the 8th coin, that is R3. So R3 should be equal to 3 mg. So the second statement should be correct. So second answer can be considered as the answer. Let's move on to the fourth statement. The force exerted on the 7th coin from the 6th coin is mg towards vertically upward direction. So R4 equal 4 mg. It's also correct. So the second and the fourth statement can be considered as the correct answers, right? හරි. අපි යමු එහෙනම් ඊළඟ පේජ් එකට හරිද? right. 13 තියෙන්නේ මෙන්න මෙහෙම සීන් එකක්. There are two objects of 12 kilogram and 7.5 kilograms are connected by using a string, even though it is having a mass, right? So this string having a mass with of a 0.5 kilogram, right? So let's assume that these are the values of the mass of relevant object, that is 12 kilogram, 7.5 kilogram, and the mass of the string is 0.5 kilogram. And this 12 kilogram object exert a force of 20 Newton. Right. That's mean right. Okay, now here just need to be something to do, something to remember. Otherwise, the answer is obtain a wrong one, right? The thing is, now if this string having a mass, that's mean the tension throughout the string having a different values. So let's assume that if there's a normally the question is given a massless string. So if it is a massless string, the string doesn't having the string having a constant tension throughout the string. But if it is having a mass, that's mean the tension of each point having a different values, right? So then now if this string having a mass, so that's mean this the string having a different tension at the ends, right? So let's apply the forces which is exerted on this object, right? So I have explained you that if I consider the free body diagrams, that's mean if I isolated the forces which is exerted on the object, let's consider whether this is the 12 kilogram object. So these are the forces which is exerted on this 12 kilogram object. Right. Keep in mind that this T1 which is marked on the string is exerted on the 12 kilogram object, not on the string, right? And this 2T is exerted on the 5 kilogram object, sorry, 7.5 kilogram object, not in the string. But if we isolate the string, so this is the way that we mark the forces, mark the tension forces on the string. It should be marked in the opposite direction, right? So let's assume F equal ma for each object. Now every object experience a same force, right? Sorry, same acceleration. That's mean 20 minus t1 equal 12 ma. Let's if we apply the F equal ma for this object, it should be t2 equal 7.5 a. If I apply the F equal ma to the string, then it should be substituted as T1 minus T2 equal 0.58, right? So let's consider this one as the first one, this is the second equation, and this is the third one. So let's add these equation each other. So then you can able to figure out if you write these equations, you can able to observe that this plus t1 is cancelled to the this negative t1 is cancelled with this positive t1. This plus t2 is cancelled with this negative t2. So I'm not going to write the whole expression, but I will obtain the final one. That's mean if you simplify it, you can able to obtain that 20 equal 20a. That's mean a equal to 1 is minus 2. So now we have to obtain the value for t2 and t1. So let's substitute the second one. If it is, then T2 can be obtained as 7.5 Newton. So this is the answer for 2T. To obtain the value for T1, let's substitute this for the first equation. Then 20 minus T1 equal 12 into A. That's mean T1 equal to 8 Newton, right? So the answer should be the C. That's mean third one. Right. In the 15th question, a ball A is moving with a velocity of 5 to collide with ball B in rest. Right. This A ball is moving with a velocity of 5, which is with the B object, which is at rest. So this is the B, this is the A. Masses A and B are 10 and 5 kilogram respectively. What would not be the velocities of A and B after the collision? Right. This one is a 10 kilogram, the other one is 5 kilogram. Okay, let's substitute, let's consider after the collision, the velocity of A object as v1 and the velocity of B object as v2. So these are the velocities just after the collision. Right. Now we are going to apply the momentum conservation law for this instance, right? Um, let's apply this equation in horizontal direction. Linear momentum conservation law. We are applying linear momentum conservation law. So this instance, this should be considered as the just before the incident, and this should be considered as just after the incident, right? So then we can able to obtain that these expressions, right? I think you might have idea of how to apply the equations, isn't it? Right. So if I cancel this 5 in each term, then 10 equal to 2v1 plus v2. So this is the expression that we can able to obtain by applying this momentum conservation law. But even though we can able to obtain the accurate value for v1 and the v2, but the question is asking about what would not be the velocities of A and B after the collision, right? So I think it's better to substitute those values. So let's start from the second answer. So here it is given V1 as 3 and V2 as 4, right? So let's substitute this value. So this is the answer in the second one. So if it is, let's substitute this 2V1 plus V2. So if it is, the answer is obtained as a 10. So it should be correct. So this couple should be can be accepted as a value for V1 and V2. And likewise, let's move on to the third one. I'm labeling it as C, right? So here, the V1 is 2 and the V2 is 6, right? Then let's find out what is the value after substituting this expression. That is 2V1 plus V2, no? 2 into V1 mean 2 plus 6. So it is also given that answer as the 10. So this couple should be also can be considered as a obtained value, right? So likewise, if you go through this answer of each couple, you can able to figure out that when you substitute the first couple of answers, right? That is V1 also having a 10 over 3 as well as the V2. Let's substitute this for this equation. 2V1 plus V2. 2 V1 meaning 10 over 3 plus 10 over 3. So here, the 20 over 3 plus 10 over 3, that's mean answer should be the 30 over 3 mean 10. Alright, sorry. This one also can be considered as the correct value, correct answer, right? Do I made a mistake? Let's substitute the fourth answer, fourth couple. That is 2V1 plus V2. 2 instead of V1, it should be 5 over 3 plus V2 means 20 over 3. Right, so this one also can be considered as the correct one. So what should be the answer there? Alright. Right. So apparently, each value should be correct when substituting this obtained expressions, isn't it? Right? Right. So this set of answers are is correctly adjust to the obtains expression. So this the answer for this question is can be considered as the whole, right? Because there's no any particular answer for this question. So that's why I'm considering there's an issue in the answers. So that's why let's consider the this can be considered as a free given mark, right? Okay. In the 16th question, a uniform L length straight rope is placed on a smooth horizontal table. Force F is applied to one terminal of the rope. The tension at a point which x distance from the other terminal is. Right. Now let's consider whether this is the string, right? So the length of the total length of this string is equal to L, and it is experience and F force at this end terminal, and we are asking the tension of a point which is this distance from the opposite terminal, right? පුතේ මේක තමයි කතන්දරේ. ඔය ගාන කියන කතන්දරේ ඕකයි හරිද? So we have to find the question, the tension at this point. So I have explained you that in order to obtain the tension at a particular point of a string, just break this string at this point into two pieces. Then it can be considered as this is the one string part of a string, and this is the remaining one, right? So this I am asserting on a force. If I mark the tension, right? So when I mark the tension forces at this point, it should be marked as T, and it should be marked as the opposite direction, right? So this is the first thing that you need to highlight in this question, right? And the other important thing is, if we consider a uniform string, the mass can be given as a ratio of a length, right? So keep in mind that because mass can be given as a part of a distance, right? So mass can be given as a distance, right? So in this instance, this part of the string the mass of this part of the string can be considered as L minus 1, and this one can be considered as a X, right? Okay, now this string is kept on a smooth surface, so there's no friction force. Let's apply the F equal mu for this part. Then it should be F minus T equal, instead of M, we can able to substitute it as L minus X into A. Let's apply the same equation for the remaining part, that is F equal mu, and it is experience a T force. M can be considered as X into A. This is the second one, and this is the first one, right? So now we are asked to find the tension, isn't it? So I think it's better to obtain a value for A in terms of T. And next, so let's substitute this value for the first equation. Then F minus T equal L minus X into T over X. If I further simplify it, LT over X minus XT over X. So this X is easily cancelled. Then F minus T equal LT over X minus T. So this should be cancelled. Then T, we can able to derive an answer for T as Fx over L. Right? So this is the third one should be the answer. Okay. In the 17th one, two M1 and M2 slices of tube are placed on a horizontal smooth table as shown in the figure. Horizontal F force is applying on the mass M2, the reaction force between two masses. Right. So these are very simple questions, right? You just have to idea about the marking the forces. Right. So this object is kept on a smooth surface, so that's mean there's no any friction force, right? This object experiences a capital F force, and due to this contact between these two surfaces, is it exerted a normal reaction? Let's call it as R. So the question is also asking about the reaction force between the masses. So that's mean this R, right? So this both object moving in the same acceleration, right? So if I apply an equation for M1 object, this is the mass of this object as M1 and this one as a M2. If I apply an equation for M1 object, it should be R equal M1A. If I apply the same equation for the M2 object, so it should be forces should be applied as F minus R equal M2A. Now we are asked to find the R, right? That's mean I'm obtaining a value for A by considering this equation and substituting for the other one. Then F minus R equal into, instead of A, I can able to substitute it as R over N1. Then I'm taking this R into the opposite side, then F equal R plus into R over N1. Then F equal R into 1 plus N2 over N1. And this is the answer. So I make the further simplification in this side. We have obtained that is that correct? Right. So if I obtain the common denominator as M1, this should be substituted as M1 plus M2. Right. So the answer can be obtained as F M1 over M1 plus M2. This is the answer, right? So this answer can be obtained in another easiest method, right? But even though I'm more preferring use the most extended procedure. So the answer should be the third one. So the third answer is the correct one for the 17th question, right? So in the 18th question, a man with mass of 60 kilogram is connected with a system of pulley as shown. The force must be applied on the string to lift him from the floor, right? So first of all, let's mark the forces on this diagram. And another string is attached to the man, right? So this is the guys, at the exam, just mark those forces on the paper itself, right? You don't need to draw another diagram. Just mark the forces on the given paper. It would be very easy, right? Okay. Now, the question is asking about the. So first of all, now keep in mind this little thing, that is, now this man is going to lift up from the floor, right? So if the man is going to lifting up, that's mean the contact between the ground and the foot and the feet is getting lost. That's mean, now normally if a person standing on the ground, if a person standing on the ground, there's a normal reaction exerted on this man from the floor, isn't it? So we can able to mark it as R1 and the R2, right? So, but if the man is going to raise from the, or if the man is going to lift up from the ground, the contact between the feet and the ground is lost. So that means there's no any normal reaction exerted at this point. So keep in mind that, right? Okay, so I'm marking the forces T1. So this also should be T1. So this is a string, and if this string is marked as a T2, and it is whirled around these both pulleys in the same one. So this tension throughout the strings should be equal, right? Okay. Now if there's another force which is exerted on the man, that is 600, that is weight, right? So if we consider the man, there are three forces exerted on the man, that is T1, T1, sorry, T1, T2, and the weight of the person. That is T1 by considering the man. T1 plus T2 can be equal to the 600. So this is the second equation. And now we are asking to obtain the find for a value for T2. Then here, if you consider this pulley, the forces acting on this pulley, you can be able to figure out that 2T2, 2T2 it can equal to T1 because this pulley is a massless object, right? So in normally in MCQs we consider that the pulleys and the strings it doesn't having a mass, right? That's why I'm considering the tension throughout the string is a constant value, but this is a different string, so that's why I'm considering two values for these two strings, right? Okay, right. If I substitute this value to the this one, then 2T2 plus T2 equals 600, then T2 is equal to 200 Newton, right? So the answer should be the second one. So likewise, guys, these are very simple questions, right? The thing is you have to adhere for this kind of simplification, right? Let's move to the 19th one, right? The forces acting on a leg shown below. If the thrust force acting on the toes by the floor is F, then the tension T would be, right? So normally this angles is given is more most probably these angles is given as a 30, 60 or 45, right? And but here they are given as a 70, right? Even though let's forget about the values, but just concerned about the theory which is in these questions, right? Now when you look at when you're looking at the question, you should have to identify that. So the forces exerting on this uh, the this foot has marked, right? The only thing is you have to apply the certain theorem, right? So if you go through this answer or if you go through this diagram, which is labeled the forces, this F is set on this direction, and there are another two forces marked as H and B. Here we have the T force and the angle is should be equal to 70 degrees. And this one is considered can be considered as the 60 degrees, right? Okay. Now, first of all, guys, you might remember now in this question there doesn't uh, concerned about the V and the H. So that's the first thing, right? They are not considering about the V and H. The question is asking about the to obtain a value for T, but the answers is given as in terms of F, right? So then you should have to identify that, right? So that's mean I do need to consider about the T and the F, not the H and the V, right? Okay, and this then now here the distance is given. So that's mean if the system is in a equilibrium state, right? So there now you know that if the system is in equilibrium state, we can able to apply two theorem for the equilibrium state object. So that is what is it? What are they? First one is the forces exerting on the resultant force exerting on the object is zero. The second one is the net moment of force at any point is equal to zero, right? So if the distance are given, that means it's better to obtain, it's better to concern moment of force from a particular point, right? So that point might be, it's better to concern this point as this one, right? Because if we obtain the moment around this point, we can able to neglect the B and the H, right? Okay, that's the first, that's the second thing that we need to identify. The other thing is, normally we are considering, we are obtaining the moment by considering the vertical and the horizontal plane forces, right? But in some instances, like this question, we have to consider the moment in the other planes too. So if you consider this diagram, I think you might a, a huge headache about this, the way these forces is marked, isn't it? So I think it's better to rearrange this T and F in a simple direction, right? Now, guys, now in if you consider a inclined surface, we are considering two planes. The one thing is perpendicular to the inclined surface, the other thing is parallel to the, or the, along the inclined surface. So remember the forces that we resolved in a force that which is acting on a inclined surface, right? So likewise, you don't need to worry about this V and H, but we do have to consider about the T. If I resolve the T into the parallel to this inclined surface, as it can be considered as T cos 7T. If I consider the vertical forces, it should be T sine 7T. If I consider the same thing for the F, it should be considered as F sine 6T. The other one should be labeled as F cos 6T, right? And if we consider now, let's consider this B and H forces, right? So now I am going to obtain the moment around this point. If I consider the moment around this point, B can be cancelled, H can be cancelled, as well as this T cos 70 and F cos 60 can be also cancelled, because both these forces is going through this point, right? That's the point which is we are considering the moment, right? So these two forces can be neglected. Okay, now the remaining forces are T sine 70 and the F sine 60. I'm considering the moment around this point. Let's call it as O. Right. This distance is given as L over 4. This one is 3L over 4. Right. Okay, if I consider the moment around this point, then this can be written as, this one should be positive, that is T sine 70 into L over 4. This one should be minus, isn't it? If sine 60 into 3L over 4 equal to 0. Then T sine 70 into L over 4 minus F into sine 60 into 3L over 4 equal to 0. That's the thing that we can able to obtain by considering the moment of force, right? So this 4 is cancelled, L is cancelled, then T sine 70 is equal to F sine 60 into 3, right? So by simplifying this expression, we can able to obtain an answer. But normally in MCQs, they are given some exactly value, trigonometry values. They are normally they are didn't give this kind of values, right? Because then we have to consider the sign table, right? However, if you obtain up to this, just correct whether it is a, whether it has the answer, right? Okay. And there's another That's a beautiful questions in the 20th MCQ. Right. Just watch carefully. Right. So if I mark the forces, which is A, B, C, D. Right. Guys, before go to the question, I just like to recall some theoretical points which is related with these questions, right? Okay. Now, to obtain the resultant force or resultant vector, there are two particular theorems. So, what are they? That is the triangle theorem and the parallelogram theorem, right? If we do it, just consider about the, let's focus about the triangle theorem, guys. If we represent two forces, two vectors in an adjacent side of a triangle, then the remaining side, which is joining from the initial and the from the initial to the final position, is represent the resultant force of these two vectors or two forces, right? So let's take another example. Assume that they are given as x and x. So the resultant can be obtained because these forces is initiate the marking at this point and end up this at this point. So the resultant can be considered as the x. Right? So this is the way. Let's take another example. Let's assume that you are marked two forces as 2x and 2x according to the particular angles, right? So then, guys, we can able to represent the uh, resultant vector of these two as this. The magnitude is marked as the 2x, right? And let's take another one. Fine. Let's assume that there are three vectors acting according to this, right? So if it is, we can able to consider that this one as x. Now towards upward direction it has 2x and downward direction it is 2x. If we consider the sum of these two vectors, we can able to mark this at x towards the upward direction. So the resultant can be considered as the x, right? So this is the way that which is behind this theory, right? Okay, so these are the some relevant theories which should be used to obtain the answer, right? Okay, right. Guys, you can able to understand that there are two EA, two FE. Right. So just focus only these two forces. So this marking of these two forces is initiated, can be initiated at this point, and it is ended up at this point, right? You just consider about the some simple forces, not concerned about the whole vectors, right? Just initiate the solving from the easiest point. So then, so resultant of these two forces can be marked as 2 EF, isn't it? Is 2 EA, right? But even though, so if you mark this vector of the resultant vector instead of these two forces can be, or these two vectors can be neglected. But even though there's a force, there's a vector is already marked in this line, it is also considered as EA. Right, so that's mean there are two EA and one EA. That means three EA is asserted along this side, right? And there's a 3AB which is asserting this side. So that's mean we can able to consider this one as right. So these two 3A is initiated from here and it is further extend up to B. So instead of these two vectors, this 3EA and 3EAB, I can able to mark this the vector as the resultant as the 3EB. Right? Just concern the values and the direction. So if you consider these two forces, so if we apply these two vectors according to the triangle theorem, the remaining side which is joining the initial and the final position represent the resultant vector. So that should be 3EB, isn't it? Right? Okay, now that it is also correct, right? Even though there's a force, there's a vector which is already marked as BE. So that's mean, according to the theory which is mentioned in the previous question, I can able to consider that I will only draw the relevant parts only, right? So that's mean, guys, instead of 3EB along the side in upward direction and BE in the opposite direction, that's mean the resultant of these two can be considered as 2EB, right? Then there's 2CB and EB, EBC. Right. So just keep in mind that now resultant of ED and BC can be represented as EC. Instead of these two, the resultant can be represented as EC. So that means there are two EC toward this direction, isn't it? Right. You don't need to draw the 5 or 4 diagrams, right? I just draw these diagrams to show the way that we obtain the answers, right? So EC can be represented as 2EC, this one as 2CB, and there's another vector which is 2EB and towards this direction, right? So you can able to figure out that instead of these two forces or these two vectors, I can able to mark 2EB instead of these two vectors, right? So that's mean the final answer should be the 4EB, right? So the answer should be the second one. Right. So in the 21st question, so it is very easy one. An object is in equilibrium on a rough inclined plane. What is the most correct force diagram? So it should be definitely it should be first one, isn't it? Because now if you kept an object on an inclined surface, this object tends to move downwards, right? So hence the friction force should be exerted on the opposite direction, and the normal reaction is also should be exerted in a perpendicular to the surface, and mass weight should be of this object should be exerted in this plane, right? So this is the correct answer. Right. So in the 22nd question, right. So let's assume that if the trolley is at rest and this another man is initiate the motion with the u velocity towards opposite direction. But this velocity is given velocity of man relative to t. I mean a capital N mean man, t mean trolley, right? So this velocity should be u towards the opposite direction. So when the man is initiate the motion, this trolley is initiate to move towards the opposite direction, right? So according to the given data, we can able to figure out that this v is given velocity of trolley relative to the earth, that is v towards opposite direction, right? So if I apply the momentum linear momentum conservation law towards this direction, then it should be considered as the initial velocity, initial momentum should be zero because initially both this trolley and man is at rest. But even though when this man is moving to walk towards the opposite direction, this trolley tends to move towards the other side, right? That's mean capital N into V minus, right? So keep in mind that when you substitute the velocities for this question, we have learned that the velocity should be substituted relative to the one single frame, right? So now here, this velocity of the trolley is given relative to the earth, but the velocity of the man is given relative to the trolley, right? So that's mean it should be converted into the velocity of man relative to the earth, right? So otherwise, this application is incorrect, right? So first of all, let's find out the velocity of man relative to the earth by applying the relative motion concept, right? That's mean we can able to derive another equation like this. Velocity of man relative to the earth mean velocity of man relative to the trolley plus velocity of trolley relative to the earth. So this one is learned at the relative motions, right? So I think you might remember this thing. Then VMT is equal to U plus PTE should be towards this direction. And so if I apply this, if I substitute this values, U minus V towards this direction. So that's the velocity of man relative to the earth. So this one should be substitute at this point, right? 0 equal mv minus simple m u minus v, right? So if I further substitute, further simplify it, I'm taking this term into the opposite side, that is m u minus v equal capital M. Then m2 minus mp equal m capital mp. So if I take this mb to the opposite direction, then mu equal m plus simple m into v. Then v is equal to mu over m plus simple m, right? So the answer should be the fifth one. Right. In the 23rd question, consider the given statement about the object in equilibrium under a system of coplanar forces. I have discussed that there are two requirements should be satisfied in order to remain the equilibrium position, right? So both these requirements should be fulfilled, right? If let's assume one requirement is fulfilled, not the other one, so that means we don't consider that the object is at rest equilibrium position, right? Both these concepts or both these requirements should be satisfied. That's the only requirement. The algebraic summation of the moment of force must be zero at least one point of the plane. That is incorrect, right? Because the algebraic summation of the moment of force of each point should be zero. Otherwise, it is not considered as the equilibrium state, right? In the B, it must be complete at least one of the following condition. The algebraic summation of moment of force must be zero about all the point of plane. That's correct. The resultant force must be zero. That's also correct. But even though both these requirements should be satisfied, right? Not only one. So that's the only issue in this statement, right? Because they are mentioning that at least one, if not at least one, is both should be satisfied. Both should be satisfied, right? So in the C part, the moment of resultant must be zero around the all point of the plane. Understood? So the answer should be only the C. Third one. 24th question. The measurement would not be obtained from spirometer. The measurement that need to find internal radius of the spherical surface. The measurement that need to find the external radius of a spherical surface, right? Now, let's assume there's a spherical surface. Now, by using spirometer, we can able to obtain the right. Normally we don't use to measure the diameter or radius of a spherical shaped object, right? So that was for obtain to this to obtain this diameter, we use micrometer instead of spirometer, right? So the first and second answer should be incorrect, right? So let's take this one. I think 4, 5. The question is asking the measurement would not be obtained from the spirometer. The thickness of a glass slide can be measured using a spirometer. It's obviously correct, right? Internal diameter of a cylindrical tube. Internal diameter of a cylindrical tube. So diameter it is cannot be obtained by using a spirometer, right? Because we can't able to insert the particular parts to this internal surface, isn't it? So the fourth one is incorrect. To measure a linear expansion of a rod, so that can be measured. Expansion can be measured using a spirometer. The other thing is the measurement that need to find external radius of a spherical surface. Right. So by using some method, we can able to measure the diameter of a spherical object, and it should be the external diameter, right? So let's assume that we obtain the external diameter, and then the external radius can be obtained by dividing two the, of the diameter, right? So the external diameter can be obtained in some way, in somehow, but internal radius is cannot be measured, right? So the first and third, fourth, first one or fourth answers can be the answer for the 24th question, right? Okay, in the 25th question, Let's solve this question on the other side. Right. I think you have go through the question. Two AB wooden blocks are connected with a pulley as shown in the diagram. The floor is rough and the pulley is light and smooth. The force P is enough to slightly move the two blocks. That's mean we can able consider that the system is still is in equilibrium state. The frictional force between it and B is 5, and it is between B and floor is 10, right? Find the tension of the string. Okay. First of all, just mark the forces on this diagram. So this, by exerting P force, this A object is tends to move towards this direction. That's mean a friction force exerted by the B object on the A object towards the opposite direction, and it is equal to 5 Newton, right? And this is the tension of the string, right? So when this object is moved towards the right side direction, this B object tends to move towards the left. So that means the surface is exerting a friction force of 10 newtons towards the opposite direction. And I forget to mark this 5 newtons is also exerted on the B object. Why? Because this friction force is exerted by the B object on the A object, right? So according to the Newton's third law, there's the opposite force should be exerted on the B object too, right? Okay. Now guys, let's isolate the B diagram. So that means T equal to 5 plus 10, isn't it? So T should be equal to 15 Newton. Right? So it is very easy question. So that's the answer for the 25th question. Right. So let's move on to the structured essay questions in this term test paper, right? Okay. In the first question, the velocity time graph of a player A who is running 100-meter event is shown below, right? And there's a small mistake in this diagram. That is, there are two graphs plotted in this table, right? Sorry, in this graph. So I think it's the main, the first one should be this one, right? Okay, so this is the graph which is related for the initial questions, right? So this there's a player who is called A, and he is participating 100 meters event, right? That's mean you have to figure out that the distance which is traveled by this A is equal to 100 meters, right? So initially, up to 4 seconds, this man is moving with acceleration. At the end of 4 seconds, this man is obtained the maximum velocity, and it is 11. And after that, he's moving in a constant speed at the end of the race, right? So that's the the main thing that we can able to obtain by looking at this graph. First one, what is the acceleration of the player, right? You might remember that today we can able to obtain two things by looking at the velocity time graph. First one is we can able to obtain the gradient of this graph, and the gradient represent the acceleration. And if we consider the area of a certain part is represent the distance traveled by the object, right? Or the travel by the person. Okay, now if you want to obtain the acceleration of this athlete, we have to consider the gradient of this graph. The gradient can be obtained by delta y over delta x, right? So that's mean delta x, delta y represent this part. This is the part which is represent the delta x, right? So delta y, that's mean equal to 11. Delta x should be equal to 4, and this is the acceleration which is obtained by this person. And you can able to figure out that this man is moving with the constant acceleration, isn't it? Okay, in the B, what is the displacement of him at the first 4 seconds, right? So as I mentioned earlier, we can able to obtain the distance traveled within these 4 seconds by considering the area of this graph of this triangle shape, right? So this is the way that we obtain the area of a triangle. That's mean 22 meters have displaced with this acceleration. Third one, what is the total time taken by the player to finish the game, right? So now you should know that, you should have to identify that this person is completed 22 meters with the acceleration, and the remaining portion and the remaining distance, that's mean 78 distance, right? Because the total distance is 100. If I subtract 22 from the 100, it should be 78 meters, isn't it? So this distance is traveled with a constant speed, right? So if the person is moving constant speed, so let's assume that this area, the area of this rectangle represents 78, right? So let's assume that this time period as t1, then 878 can be obtained by multiplying 11 from t1, then t1 can be approximately equal to 7 seconds, right? But the question is asking about the total time taken by this player. Then total time today, he moving with the acceleration of 4 seconds plus 7 seconds with the constant speed. So that means total time is 11 seconds. Right. Then in the fourth question, player B, that's another athlete, is running with uniform acceleration at the end of 7 seconds. So just keep it concerned this statement. At the end of 7th second of the play, the player A was passed by the player B. Draw the velocity time graph of the player B on the above given axis. So that's the that graph is also mentioned in this diagram, right? So that's the only mistake we make in this question, right? So let's forget about those stuffs. So let's assume that today this is the place where the at the 7 seconds A was passed by the B. That's mean now if I draw a simple diagram, both A and B initiate their motion at the same time, at the same position. Let's assume whether this is the finishing line. Whether this is the finishing line, right? So you can able to figure out that this is A represent the graph for the A person. This one is represent the graph for B person, right? So I think initially A might have obtained a good speed and moving further, but initially B is, I think he's might be just behind the A, but at the seventh second, if B is A is passed by the B, that's mean both A and B have traveled with the same distance. That's the meaning of passing, right? This is the place where this is the point where the B is A was passed by the B. Right. So at this point, if the both these player initiate the motion at once, that's mean they have traveled same time as well as they have traveled the same distance. So this should be identified by looking at this diagram, right? So the distance traveled by the A and the B should be equal as well as the time, right? So in the fifth question, now you are asking to draw this diagram. This is the fourth question. And fifth one, what is the displacement of the player at the end of the seventh second? So what is now you are asking to obtain the distance which is traveled by the B, right? So distance traveled by B person is equal to the distance traveled by A, right? Because that's at the 7 seconds. Right? At the 7 seconds, both these athletes traveled the same distance, right? But now, if you want to obtain the, let's assume the velocity at this point of B person as V1, right? But if we apply an equation for B, this is the way that we can able to obtain the distance. That's mean area of this triangle. B1 into T. T equals 7, isn't it? But even though we can able to obtain a value for x by obtaining by considering this expression, isn't it? Right. But it is if it is equal to distance traveled by the A, we can able to obtain the distance traveled by this 7 seconds of this A person, right? We already know that after 4 seconds, he has traveled 22 meters, right? After at the end of the 4 seconds, he has traveled 22 meters, right? So that's mean the remaining portion, that's mean area of this rectangle represent the distance traveled by the A object within this t time, right? Distance traveled by B, sorry, A person from T4 to T7. It can be obtained by considering the area. That means 33 meters. Right. So at this end of the 7 seconds, A have traveled 22 plus 33. That means 55 meters. So it is the distance traveled by the B at the 7 seconds, right? So this one is useless for the in obtaining the answer, right? But even though it's fine, it's completely fine if you write down this kind of expressions, right? Even though at least you give a try, no? Okay. Now in the sixth question, find the velocity and the acceleration of the player B at that moment. Right. So at this point, to obtain the V1, we can able to use these expressions, isn't it? Right. So we already have find the value for x, that is 55 equal to half into V1 and 7 into 7. That's mean V1 equal to 110 over 7 in this minus 1. In order to obtain the acceleration, now you know that acceleration can be obtained by considering the gradient. Gradient is can be obtained by using delta y over delta x. So here, at the end of the 7 seconds, this is represent the delta y, and this one represent the delta x, right? Then delta y is equal to 110 over 7. Delta x also equal to 7. That's why, that's mean a equal to, this is the value of acceleration, right? Okay. Now in the seventh question, you are asked to find the what is the distance, what is the difference between finish times of two players, right? Right. So now we have derived that a person taken 11 seconds to complete this race, right? Likewise, we have to find the time taken by the B person to complete this race, right? So if I draw another diagram, these are not essential for you, but I'm just considering to express to explain this answer very clearly. So that's why I'm using these diagrams, right? So let's assume that today, if the person is complete the race at T point, this is the diagram for B, then, and let's assume that the velocity when he just passed the finishing line as V2. So you know that the area of this diagram represents 100 meters, right? So by considering the area, we can able to write an expression as half into V2 into T2. Sorry, T naught. But without having an idea of V2 or V2, without having an idea for V2, we can't able to obtain an answer for 100. Right. So then let's find out let's give some effort to find the V2. Right. And we have another clue, that is acceleration represented by delta y over delta x. Delta y over delta x. Because this B person is moving up to the finishing line with the same acceleration, right? So then we already have obtained a value for A, that is 110 over 49 equal to delta y means V2, delta x means T naught, right? So we can able to obtain an answer for V2 in terms of T naught, that is right. So let's substitute this value for this obtained expression, that is 100 equal half into, instead of V2, let's substitute this one into T2. That's mean today T naught squared can be obtained by so this is the answer. So if you calculate it further, we can able to obtain an answer as the T naught as the 9.4 seconds, right? So today, this is the time which is taken by the B to complete the race, and this is the time which is taken by the A to complete this race, right? Okay, so that's the end of the first structured essay question. Right. So in the second paper, second question, the structured essay paper, you are asked to some related things with the micrometer screw gauge, right? Mass of small sphere is 10 gram that is placed between A and B of a micrometer screw gauge. Name the parts of that indicated by the letters. Right. A should be anvil, B should be a spindle, C can be considered as sleeve. Some of you might mark it as a sleeve, or some of you might be labeled as main scale or linear scale. Both all of these answers is correct, right? D mean is the obviously circular scale, but some of you might label it whether it is as a thimble, right? That is also can be accepted, right? Thimble. Both these were used to represent the same thing. Okay, E mean thimble head. It is obviously it is called as a thimble head, or it also can be considered as the ratchet, right? Right. Okay. So in the first one, denote the forces acting on the sphere when it is tied between A and B on the shown diagram, right? So this spherical object is kept between the anvil and the spindle. So you are asked to mark the forces, right? Right. So these two, and this anvil and the spindle exert a normal reaction towards this object. So it should be marked as R1, and this one should be marked as R2. And don't forget to label the weight of this object, right? So these are the forces which is acting on this spherical object. Second one, how do you verify that sphere was tight as seen up, right? So when we now you know that when the spindle is close enough to the spherical object, we are rotating thimble head, right? So when the spindle is come to the contact with the object, the thimble head generate a sound tick tick. It's called tick, a sound called tick tick, right? So if there's a sound generating, if the tick tick sound generating from in the thimble head, that's mean we can able to confirm that there's a close contact between the spindle and the object, the surface of the object. So the answer should be the generating tick tick sound from the thimble head. Right. To obtain this sound, we should rotate the thimble head when the spindle is getting close to the surface of the object, right? So otherwise, you can able to obtain this sound, right? Okay. Now in the third one, the circular scale consists of 50 divisions, and we can move for 1 meter distance along the linear scale when circular scale is rotating for 2 circles, right? You might remember that today pitch can be obtained. This is the pitch mean the distance traveled by the spindle when rotating 1 complete circle, complete rotation of the circular scale now. Right. But here, uh, the spindle is moving 1 millimeter distance when rotating two circles of circular distance. But when we come to the pitch, the definition of the pitch means the distance traveled by the spindle when rotating one complete circle of the circular division. That means pitch should be equal to half of 1 millimeter. So guys, this should be the pitch, right? So keep in mind that because this can be there's a chance to misunderstand that pitch as 1 millimeter, but just go through the questions very carefully. And now we are asked to find the value or the reading of this object, right? So first of all, let's find out the least count of this least count of this micrometer. So you know that least count can be obtained by pitch dividing number of circular divisions, right? So pitch is equal to 0.5 millimeters and it should be divided from the 50. So that's mean the least count should be equal to 0.01 millimeter, right? So hence to obtain the reading, now keep in mind that the pitch of this instrument is 0.5 millimeters, right? So according to the diagram, so if this 0, this should be 0.5 centimeter, 5.5, this should be 1, this should be 1.5, and this should be the second one. This is second 2.5, this is 3, and this should be 3.5. So the the reading of the main scale should be equal to 3.5 millimeters because we have to concern the final value of the main scale. It is appeared on the main scale, right? So when obtaining the reading, we have to substitute. This is the equation reading of micrometer screw gauge can be obtained by value of main scale plus least count into coincide circular division. So that's the equation now. So value of the main scale should be substituted as 3.5 millimeters plus 0.01 millimeters into what is the coincided value should be marked as 11. So the answer should be the 3.61 millimeter. So this is the reading of this object. So this is the answer for the third one. Right. So you should have a key knowledge regarding those stuffs, right? In the fourth one, the scale of the above micrometer screw gauge is shown below when A and B are touch each other. Find the correct radius of the sphere. Now you have to keep in mind that the question is asking about the radius, but we are measuring about the diameter. That's the first thing that you need to notice. That the other thing is this object having a now in considering the zero errors, there are two types of zero errors, isn't it? One is the positive zero error and the other thing is negative zero error. Now, I have told you that if you are unable to, uh, if it is unable to visible the zero division or the half of the zero division of a main scale, that's mean it is most probably it should be negative zero error, right? So just go through the answer. So that's mean you should have to figure out that this micrometer screw gauge is suffered from the negative zero error, right? So negative zero error can be obtained by least count into total circular division, subtract from the coincide circular division. So least count is 0.01 millimeter. Total circular division is 50 and the coincide circular division is 45. So this is the answer of the negative zero error. Right. If you need to find the correct value of the reading, so this is the accurate reading, right? This is the accurate reading. Now this negative zero error should be added to the obtained value, right? So the obtained value should be added to the this one. So that's mean it should be the answer should be the 3.66 millimeters. But even though, keep in mind that this obtained value is represent the diameter of this sphere. This value represent the diameter, right? But you are asking to obtain the radius. So if the radius, so then that's mean radius can be obtained by dividing 3.66 from 2. That's mean 1.83 millimeters. That's the value for radius, right? Then you are asked to find the density of the sphere, right? So how should we obtain the density? How should we obtain the density of this sphere? It's pretty easy, right? Because you know that density can be obtained by, so density means mass over volume, right? So volume mass is given at the initially of this question, but it is given as a gram value. So you definitely have to convert this gram into kilogram by multiplying 10 into the power minus 3, and it should be divided from the. Now this is the spherical object. The volume of the spherical object can be obtained by 3 over 4 pi r cube. Then 4 over 3, pi means 3.14 into r mean we have already obtained that 1.83 millimeters. Guys, it's better to convert into meters and you have to consider the cube of this value. So this is the answer. You don't need to simplify it. Just the substitution is enough. The accurate substitution is enough to obtain the given the marks, right? Okay, in the sixth question, is that it was suitable to use the above micrometer screw gauge to obtain the value of the above? Right, give reason for your answer. Right, so this can be used because normally keep in mind that this radius, the value of the radius is 1.83 millimeters, right? So the least count of this instrument is equal to 1.01 millimeters, right? And keep in mind that, guys, um, the every reading should be kept. Now, this least count is given for 2 decimal points. It is given for 2 decimals. So the every reading or every value should be kept for the 2 decimals, right? So the radius is given for 2 decimals. That's why, so this can be obtained by using this mentioned micrometer screw gauge. Right. Okay. So this is the end of the second structured questions, right? Okay, let's move on to the third question. So that is, it is a an essay part, right? Right. So this is the third question of the second paper, and it's the first one in the essay questions, right? Right. A balloon. A balloon is moving upward with a 15 uniform vertical velocity. A stone is freely released from the balloon at a point 200 meters above the ground. At the same moment, a separate stone is thrown vertically upward with 15 ms minus 1 vertical velocity. Right. Right. So let's draw a simple diagram. That is now the initial stone is released from a balloon which is moving upward with the constant velocity of 15 ms minus 1, right? So if the stone is released from a balloon which is moving with a 15 ms minus 1, that's mean when the release of this object, or when the release of the stone, this stone also consists of this 15 ms minus velocity. So that's mean we can able to consider that even it is a release, the initial velocity of this first stone should be also 15 ms minus 1, right? So that's the theory which is behind the question like this. So that's mean this stone is moving this kind of motion and up to the ground, right? So this object is released at a 200-meter height from the ground. This is the part 3 of the first stone, right? So when this object is released, or when the first stone is released, there's another second stone is moved vertically upward. So let's assume that because this is the motion of the second stone, this is the second one, and this is the motion of the first stone, right? Okay. Now, in the first one, as seen by a man on the ground, what is the initial velocity of the first stone? I think it should be equal to 15, isn't it? Now, normally we consider if the object is released, that's mean the initial velocity is 0. But even though if the object is released from a moving vehicle, that velocity of the vehicle also included for the object, right? That's why we consider the initial velocity as the 15 relative to the ground. What is the velocity of the second stone? So initial velocity, no, it is also equal to 15. Right. The second one. What is the time taken by the first stone to reach the ground? Right. So keep in mind that now you listen. If I mark this point as A and B, so I am asserting a vertically upward direction and equation from A to B. Guys, as I mentioned earlier, we apply this equation from the A point in a vertically upward direction. So if we come to the displacement, from this horizontal line, the distance displacement value which is measured from the above, from this horizontal line, is considered as a positive, and the displacement values which is measured below from this level is considered as negative, right? So this is the importance of correctly apply this sign, right? And you are given a displacement value and asking about the time, so it's better to apply the x equal ut plus half AT squared. Then x should be substituted as minus 200. Right? Keep in mind that. So it should be substituted as minus 200 and initial velocity should be 15. Let's call the time as t1 plus half. Then 10. This acceleration also should be substituted as minus 10 and t1 squared. 200 15 t1 minus 5 t1 squared. So if I divide all the terms from 5, then I can able to obtain that minus 40 equal 3 t1 minus t1 squared. So I think it's better to arrange this quadratic equation with the positive coefficient of square term, right? So then if it should be t1 squared, let's take these two terms into the other side. So then it's converted to minus 3t1 minus 40 equal to 0. Right? Then let's find out the factors R-axis. So it's obviously t1 squared minus 8t1 minus, sorry, plus 5t1 minus 40 equal to 0. Right. You can able to figure out that t1 minus 8 equal to 0 or t1 plus 5 equal to 0. So the answer should be the t1 equal to 8 seconds because time cannot be a negative value. So the answer should be the t is equal to 8 seconds. Third one, what is the time taken by the second object to reach the ground? So that's mean, now let's consider the motion of the second object. It is initiated from the C and is come to the return to the same position. Right. So let's apply from the in equation in vertical upward direction for the second object, right? So that means if the object returns to the same position, initial position, the displacement should be equal to 0. U mean 15. And let's consider the time taken by the second stone to reach the ground as T2. Then it should be substituted as 15 T2 plus half minus 10 T1 squared. Then 15 T2 minus 5 T2 squared. So when this term comes to the opposite side, 5 T2 equal, sorry, 5 T squared, T2 squared equal to 5 T2. Then we can able to simplify this, and T2 is equal to 3 seconds. Right. This is the answer for the third one. What is the time difference between the second and the third? That's mean 5 and 8. So the answer should be the 3 and 8. So the answer should be the 5 seconds. This is the time difference. Right. Okay. So let's move on to the next part of the third question. Now it is related with the projectile motions. So in the B part of the third question, a battle aircraft is flying at a velocity of 72. 72 ms minus 1 speed at an elevation of 128 meters from the ground. To attack an array of identical trucks moving along straight road with different constant speed. Now this truck is moving in a constant speed, right? The dimension of a truck is 10-meter length and 3-meter height. So let's assume that this is a truck, and this truck having a 10-meter length and 3-meter height. At the instance a bomb released, right? So that means the bomb is released freely from the battle aircraft as make 125-meter horizontal displacement with the rear edge of the truck, right? So that's mean when this bomb is released, there's a 125-meter distance between the 125 horizontal distance between this point from the rear side of this truck, right? So this truck should be moved toward this direction, right? Find the velocity of the truck if it was completely destroyed, right? Find the right. So let's now then let's assume that whether this the velocity of this truck has v naught. So this is the positions of the bomb and the truck when the bomb is released from this aircraft, right? So now what happened? Let's assume that when the bomb is released, this truck is also moving towards this direction, right? So let's assume that now this is if this is the now keep in mind that if the bomb is released, the bomb having initial horizontal velocity of 72 ms minus 1 and the vertical initial velocity is equal to 0. Now keep in mind those stuffs, right? And let's assume whether this is the pathway of the bomb, right? So that's mean now let's assume that if the t time is taken to reach the bomb towards the truck, and within this t time, this is the distance traveled by the truck, right? So let's call it as x. X mean distance traveled by truck within t naught time. And this is the time which is taken by the bomb to hit the truck, right? And keep in mind that this is the important things which is very rare things in the questions. Now they mention that this aircraft is moving with the 128 altitude from the ground, right? But even though this truck having a height of 3 meters, so let's assume that this is the place where the bomb is collide with the truck. Then the vertical distance traveled by the bomb, is equal to, let's consider it as h, and h is equal to 128 minus 3. So normally these are very rare things which is asked in a questions, but in this question it is also is asked, right? So just grab those stuffs for your mind. So when you obtain this similar kind of questions or this similar theoretical point, just remind those stuffs, right? Okay. Uh, then now we are asking about the velocity of the truck, no? Right. So let's now I'm inserting an equation is equal to plus half a square in vertically downward direction. So then now you know that this is applied for the bomb, right? The distance, vertical distance traveled by the bomb is 125, not is the 128, right? So and initial velocity is 0, 10, it should be plus 10 t naught squared. Then you can able to figure out that t naught squared equal to 25, then t naught equal to 5 seconds. Right. So let's apply the same an equation for the bomb 2 toward the horizontal direction. So this is the equation we are applying for the horizontal motion of a projectile motion. So x can be obtained as 125 plus x, isn't it? This is the distance traveled by this object equal to u means 72, t means 5 seconds. Right? So we simplify this. This can be considered as the 360 centimeters and x equal to 235 meters. This is the distance traveled by this truck, right? So let's apply an equation for the truck. Now, as mentioned in the question, this truck is moving with a constant speed, right? So if the truck is moving with a constant speed, let's apply S equal ut in horizontal direction. So this is the travel by this truck within this considering time. So it should be equal to 235 equal u mean v t mean, guys, t mean 5, right? So then v naught should be equal to, this is the velocity of the is considering truck, right? Okay. After second, so in the B part, after few seconds, another bomb was released, freely targeting another truck of uniform velocity 45. At the instance bomb is released, the rear edge of the truck, also at the horizontal distance as above case, will it be destroyed or not? Your reasons for your answer, right? So guys, keep in mind that now to obtain the answer, you don't need to worry. You don't need to go for an calculation. Just obtain the answer logically, right? So now you know that within this time period, this object, this bomb is moving this kind of motion, right? So now this truck is moving with the 47 ms minus 1. But now in the considering the second truck is moving with the 45 ms minus 1 velocity. This is moving with the 45 ms minus velocity. So that's mean, let's assume whether this is the place where the truck collide with the bomb. If it is moving with the 47, now actually the second truck should be behind the truck, right? And because it's having a this is the position of the first truck. Now let's assume that if we consider the rear surface, let's assume that the distance traveled by the rear end of the truck as y. So y can be obtained by using this equation, isn't it? For the second truck. y q is equal to 45. T also equal to 5. So this is the distance traveled by the second object. But even though now as initially they mentioned that the distance of the length of the truck is 10 meters. So even though this distance having a 10 meters, so that's mean this bomb is collide with the front end of the truck, because that means we have obtained that the if the truck is moving with a 235 distance, it should be collide with the bomb, right? So this truck is also, even the rear end is moving the 225 meters. The bomb is collide with the front end of the truck. So that's mean there should be a collision. It can be a collision.